Good morning, everyone. This is going to be our Unit 2 video on AP Computer Science A. My name is Meek, and I'm here to teach you AP CSA way better than your teachers can. Stuff we're going to cover in this video, we're going to cover stuff like classes and objects. This is going to be an introduction to objects. We're going to see that as a recurring theme in subsequent units. We're discussing mostly the basics now. We're going to discuss methods, attributes. We're going to take a deep dive into the scanner class. So let's get right into it. First and foremost, we want to try and get a conceptual understanding of what the class and the objects are. Okay, so you may remember from the first video that I used the example of a Minecraft sheep to represent an object. Okay, now in context of the data types that we covered in the previous video, that objects are going to fall into a reference data type. Okay, so an object contains a lot of different types of data. Okay, so when the computer uh, designs or instantiates, sort of creates an object, it's going to assign it an address. It's going to be a list of numbers like 6, 7, 4, 5, 8, etc. Okay, that list of numbers is going to be the object's address. And that address is, again, I'm going to use the example of a treasure map. That address is the treasure map that leads to where the data of your object is stored. Okay? So now let's zoom out to the macro. Okay? In object-oriented languages like Java, we have something called a class. Okay? And I'm going to stay with the example of a previous video when I mentioned that the sheep in Minecraft would be one of these data types, okay? So a class is like a type of thing, okay? A class in this case would be a sheep. I can have a sheep class. Class is a reference to an object, okay? So the relationship there is that you can have class being the type of thing, sheep is a type of thing, and the object is the specific instance of that thing, or a specific item. So I could have a sheep class, and then an object of the sheep class would be like a gray sheep that has 20 HP and can eat grass. Okay? You have a general structure, a general framework, which is the sheep, and then the object would be a specific instance of that class. The object would be like a gray sheep that has 20 HP and came into existence 20 seconds ago. Okay? It's like there is an abstract idea of a bike, which is a class in this analogy, and then there is my bike, which is a specific bike, which is the object. Okay? So the general idea here is that a class has empty characteristics and empty behaviors. But once I create an object of the class, I determine what those behaviors and what those attributes are. Like, I could create a gray sheep. I fill in the color characteristic. I could fill in a sheep that has 10 health. That would fill in the HP characteristic. I could create a sheep that moves once every 20 seconds. That would fill in one of the behavior characteristics. Okay, so classes are empty sheets of paper, and objects are you filling in those sheets of paper to describe a specific object, specific instance. Okay? Okay, so here I have my prompt. I'm going to first import the scanner class, and I do that by typing import java.util.scanner. Now remember, everything is case sensitive. Scanner is going to be capitalized. Okay? So the reason I'm doing that is classes are something that you would need to write, something you'd need to program, something you'd need to design. Okay, the scanner is something that is already designed, and I just need to pull that into my program. Okay, let's cover instantiation. What does the word instantiation means? That means creating a class. I'm sorry, not creating a class, creating an object of a class. So the way I would create a variable, it's a similar process. Instantiation is me creating an object. So let me instantiate an object of the scanner class. So the syntax for doing that would be, I would start with the name of the class, scanner. Then I would name the object. I would give it an identifier. I'm going to call it input. That's the name I'm assigning to it. Then the equals operator. Then I use the keyword new. Keyword new symbolizes that I'm creating a new object. Then I would call the constructor of the object, and we're going to get into what exactly that means in just a moment. This right here is the constructor for my object. It is a command, it is a function, a method that creates a scanner object of the scanner class. Okay? So whenever you see something with braces like this, with parentheses, that is a method. So the constructor method, inside the parentheses, you'll notice there is something written. That's called a parameter. Okay? It is data that we are inputting into the method so that the method does something with that data. Okay? In the case of the constructor, whatever you pass into the parameter is the type of object you are constructing. Okay? So in this case, the scanner constructor is being put with a system.in inside the parentheses. That is the parameter being fed into the constructor. So I am creating a scanner that is a system input. So, and the types of parameters you would be feeding into your methods or feeding into your constructors is dependent on how the method or constructor works, okay? And we're going to cover that more in depth when we cover writing classes and writing constructors, which is a future video. Okay, so for example, I want to show you guys if I create, let's say, an integer variable, let's say int x equals 4, I could pass in int x into the constructor. Okay, now I don't know how the scanner constructor is written. It probably doesn't accept an integer parameter. But what I'm trying to demonstrate to you here is the way a parameter is being fed in. Okay? When a parameter is fed in, the integer x is not itself being fed in. What the computer does is it says, okay, I need an integer x. Let me go find integer x. All right, I found it. I'm going to make a copy of it, and then I'm going to feed it into the method, or I'm going to feed it into the constructor. So the way that works is the constructor or the method is probably going to do something to the parameter once the method is running. Okay? So the importance of a copy being fed in is that whatever the method does to your parameter doesn't change your original value, because the method is working with a copy. It's not working with the original. So no matter what the constructor or the method does to x, it can do whatever it wants and it won't change my original value. Okay? So moving on from there, we have something called a null designation. So what is null? It is an object reference that does not have an object attached to it. Okay, so let me show you what that means conceptually. So something is called null, or it has a null object reference, if we have a treasure map, we have an object reference with a bunch of numbers attached to it, we have a treasure map, and if we follow the treasure map leads nowhere. Okay, there's no treasure at the end of the treasure map. There's no object at all. It doesn't exist. We need to create the object in order for it to exist at the end of the treasure map, okay? So the object is going to be null until we create it. That's what the null thing means. All right, so now we're going to get into behaviors, methods that are attached to an object. All right, so let's start with the methods that might be associated with the scanner class and the scanner object that I just created, okay? So input is the name, the identifier that I assigned to this new scanner object that I had just created. So let me show you how this works, okay? I'm going to ask it to collect an input from the user. Let's say I wanted to collect an integer. If I wanted to collect an integer, I would say int variable equals the value that is collected by the scanner. So that would be a method of the scanner. The scanner is doing something. It's collecting information for me. So that would be next int parentheses. That is the name of the method we're trying to use, okay? But whenever we use a method, we are going to need to specify the object that is doing the method, that is doing the action. So we use our identifier of the scanner, and we say we want input to collect an input from the user. We want this object to collect an input from the user. Okay, and I'm just going to print it out so that we can see this working in action. I'm going to print out a variable, which is the item collected from the user. We're going to compile that and run it. We're going to fix our code first, and we're going to compile and run it. And now it's waiting for an input. Let's say 4. See, I input the number 4 up here, and the code outputs the number 4 back to me right down there. So that would be an example of a method. So notice the syntax we use here. This would be an example of what's called a non-static method. A non-static method is called using the identifier of an instantiated object, of a created object. Okay? And then the method name comes after the dot. Next int is the method name, and you have parentheses placed after every method call. Okay? So if I wanted to collect, let's say, a string data type from the user, I would use this command, which is the .next, which is the next single uninterrupted list of letters. Okay? So the .next command returns a single word. It stops reading once it hits a space, and the next line command stops reading whenever it hits an enter or a line break. So if we do next line, I can put in a bunch of gibberish, I can put in a bunch of spaces, and it won't collect until there's a line break, as you can see here. Okay? Whereas if I just used the next command, it would collect the data the moment there is a space. Well, not the moment. It wouldn't collect when you hit a space, it would collect up until the space. So I called this a non-static method. What does that mean? So a non-static method is called using the name of an instantiated object. A static method does not need a name call, or depending on the static method, it's called using the name of the class. Okay, so in the case of a static method, you'd call this with the name of the class, which is capital S scanner. Okay. Moving on from there, I want to introduce us to the string class, which is a class that is very, very important to AP Computer Science A, and it is a class that is referenced on your reference table, the string class, first one at the top. Okay? So let's go over some of the methods that are present on that reference table. So the string class is not something that needs to be imported like the scanner, so we can just begin using it whenever. So the string class is interesting because I can create a string object as a primitive data type would be created and say string x equals x, or I can create it as an object like string x equals new, that's not how you spell new string, and that's the constructor for the string class. And I pass in x as a parameter because I want it to create something like this. Now let me call this my xo for x object. Okay. So this is actually the first thing referenced on your APCSA reference table, the string constructor, first thing at the top. It's the name of the method, capital S string, followed by the parameter inside the parentheses. You would feed in a string data type as a string literal, which is the string encased in quotation marks. And that would construct a new string with the characters that you passed in as a parameter. Okay? So after that, we have some other methods that we can call. For example, we can create an integer variable that holds the number of characters in our string, and that would be called with the identifier of our object with the name of the method. xo.length would return the length of that string. Okay, and we terminate all methods with the parentheses. So if we want to print that out to the system, if we want to tell the user how long our string is, we would do that by putting our num into the system.out.print. And let's see how this works. And we can see here on the terminal that we are being printed out the number 1, which is the number of characters in our string object. So that would be the .length method. And due to our analysis from before, since we called the .length method using the name of our object, we know it is a non-static method. Okay? Now, another realm of classification of methods is based on the return type. Okay? So a void method is a method that doesn't return a value. Okay, so an example of that would be the system.out.print method. That method performs an action, but it doesn't return any data type to our code. So what do I mean by return a data type? An example of a non-void method, a method that actually returns something, would be the .length method. The .length method returns an integer. This expression right here evaluates to an integer, which is 1 in this case. So that reduces to our integer num, this variable equals 1. Okay, so it returns the value 1 after the method has finished executing. This does not return anything. This would be called an int method because it returns a data type of an integer. You could have double methods which return a double. You could have string methods which return a string. You could have object methods which return an object. So let's continue working through the string class for the time being. Okay? The next thing we see here on the string class is the substring method. So you'll notice here that if you see a int or a string on your reference table that is separated from the name of the method by a single space, that is the return type of the method. So int is the preceding word before the length method, therefore the length method has a return type of an integer. The substring method is preceded by the word string, therefore it is a string return type. So the substring method is, of course, a non-static method, so it's going to be called with the name of our object. Let's rename, or not rename, redeclare, reinstantiate the string object as a different word. Let's say extra help, extra space help. Now would be a good time to demonstrate the counting system we have here in computer science. So the substring returns a string that is a subsection of the string it was called from. So let me demonstrate that for us all. Let's say string reduced equals xo.substring, and we pass in our parameters, which are from what to what. Let's say I just want the word extra, 0 to 5. Okay. Now, let's understand what's going on here. So we are going to demonstrate that in computer science, all the numbers start at 0. Okay, so the first letter in our string is going to be letter number 0. E is letter number 0, X is letter number 1, T is number 2, R is number 3, and A is number 4. And the space is number 5. Okay? So if I want to print out the word extra, I'm going to iterate from 0 to 5. Okay, and the reason for that being is I'm going to start on the first letter I output, and I'm going to end before the last index. Okay, so I am going to print out index 0, but I'm not going to print out index 5. I'm going to start at 0, and I'm going to end before 5. That's basically how the substring parameter is structured. So I am going to print that out to the system, my reduced string, the string that I named as reduced, and we'll see that this extracts just the word extra from the string. What am I printing out here? I'm printing out a 1 and a 0. Let me disable that so we can look at just the word extra in this case. So if I wanted just the word help, I would count my way up there, 0, 1, 2, 3, 4, 5, and I'd start on index number 6, and I'd end on 6, 7, 8, 9. I'd end before 10. So if I print that out, I'm going to get help. Okay? If I were to go to index 11, which doesn't exist, index 10 also doesn't exist, then I'd get an error saying an out of bounds. Okay, where does it say? Check bounds begin end. That's the error I'm getting right here. So be wary that your parameters are within the bounds of your substring. So if I just want the help part of this word, then I'm going to tell the substring to start at number 6 and proceed to the rest of the word, which is the second method. If I compile that, I get the help word printed out to me. Our next method here is an integer return type, the index of method. So I could say int ind equals xo dot index of, and this looks through the string and searches for a particular character. So if I want the index of e, or if I want the index of ex, then it's going to tell me the index that starts at. Okay? So instead of declaring this as an int variable and going through all this, I just want to print this out to the system the moment that it is evaluated. So I'm going to do just that. So if I want the index of ex, that little snippet occurs at the first index, index 0. Now, if I look for a string that doesn't exist in my word, I'm going to get a return of -1. Okay? So that's very important as we try to build on this knowledge in subsequent units. Next, we have the dot equals operator. Okay? So, like I said before, there is more than one type of equals operator. Okay? The two that we're going to be dealing with now is going to be the equals equals or the dot equals, and we're going to discuss the differences between those two. So the first type of equals is for primitive data types, let's say integers. If I want to ask the computer to evaluate this statement, x equals y, okay? This is basically saying check if x equals y. This is a Boolean statement. If x does in fact equal y, then this Boolean evaluates to true, and it returns true. Okay, if it is not true, the Boolean returns false. So if, for example, I did system.out.println, and I did num1 equals num2, and let me go and create those variables right now. We're going to say int num1 equals 4, and we're going to say int num2 equals 5. Okay, so as we print these out, we should get a false statement returned to us, because this returned a Boolean that was false. If these are now the same number, this is going to return a Boolean that is true. Okay? But what you can't do with the equals equals operator is you can't compare objects. Strings are objects. So if I create another string y that equals y, because why not? In order to accurately compare objects, you need to use the dot equals method and pass in your second object, is string in this case, as a parameter. Okay? So then when you compare the two, you're going to get a true, because in this case, you're comparing the treasure at the end of the treasure map, where if you wrote it with the double equal signs, you would only be comparing the treasure maps. Okay? And like we know, you can have two treasure maps that lead to the exact same treasure but go different paths. So the treasure maps might not be equal, but the treasure at the end is. Okay, so in order to compare the treasure at the end, you need the dot equals method. Okay, moving on from there, we have two more classes that are on your Java quick reference table, and that are the wrapper classes, WRAPPR. The wrapper classes are the function of them is to take a primitive data type like int ex equals 4, take a primitive data type and put it into an object. Okay, so I could say integer exa equals new integer ex. Okay? And what that does is now I have an integer object, exa, that contains the number 4. Okay? And you might be asking yourself, why would I ever need to put a primitive data type into an object? Well, you'll see the importance of that when we come to Unit 6, I believe, when we cover arrays and the array list. We're going to get to that when we get to that. You also have the wrapper class for doubles. You can have double exap equals new double 3.32. Okay? Wrapper classes. So after wrapping it, you can unwrap it. You can pull the primitive data type out by simply reading the data on it. Okay? So for the integer, I would create a primitive data type int pv equals the integer object that I created dot value dot int value, excuse me. And that, therefore, this method returns the integer value of my integer object. And I set that integer value into a primitive data type. And the same goes for the double example. Double ov, I'm running out of creative names, I think you got that, exap, my double object, dot double value. And that's going to return the double value stored in my double object. And moving on from there, we have the final class on your reference table that we're going to be covering today, which would be the math class. Okay, so all of the methods in the math class are static methods, which gives us a good chance to review static methods. So the first one returns an int value, and that is the absolute value function. Okay, so let's say I take num1, which is 4. Let's call it -4 for demonstration purposes. And I say system.out.print, and I want to print out the absolute value of num1. So I would call the static method, and the way I call the static method, I call it with the name of the class. So math dot the name of the method, absolute value, and in parentheses I pass in the number I want to take the absolute value of, num1. And if I compile and run that, I should get the number 4. So next on our list is the absolute value, but for double data types. I don't think you need me to redo the whole hullabaloo, but notice here that the name of the method is the exact same. Okay? So depending on which method you call is dependent upon which parameter you pass in. So if you pass in an integer parameter, then it calls the integer method. If you pass in a double parameter, it calls the double method. So that way you can write several methods with the same name, and the method that actually ends up being called is dependent on the parameter you pass in. So the next one is the power method, where math.pow, remember it's a static because I'm calling it with the class name, and it takes two parameters, the base and the exponent. So the base, let me call it num1, and the exponent, let me call num2. So what this does is it's taking -4 and it's raising it to the 4th power. If I print that out, I get 256. Next, the square root. This just simply takes the square root of a double. What is the square root of 4? It's going to be, that's not sorry, I forgot to change the actual name of the method, which is the whole thing I'm doing here. Square root, SQRT. Square root of 4 is 2. And you'll see these are returning double values, as you can see by the presence of the decimal point. Now, what is probably the most useful and most used one on the AP exam is the math.random function. So this one is a little tricky to understand. It returns a random decimal between 0 and 1. But it's important to know that it can return 0.0000, but it cannot return 1.0. It's any value between 0 and 1, including 0, but excluding 1. Alright? So math.random, it doesn't take any parameters, so I need to delete this num2. And the way this is useful is, let's say I want to program like a board game, and I want to program rolling dice. So the way I would do that is I want a random number between 1 and 6. Okay? So first of all, what I would do is I would take my math.random and I would multiply it by 5. Okay, so this gives me a random number between 0 and 5, excluding 5. I want a random number between 1 and 6, not between 0 and 5. So what I would do is I would then add 1 to that. This statement, therefore, gives me a random decimal between 0 and 6, excluding 6. But I don't want a decimal, I want a whole number. So I'm going to need to round. And if I round 5.5, it's going to round up to 6. So that's going to give me my 6 value that I need. Okay? So what I'm going to do is I'm going to encase this whole expression in parentheses. I'm going to add 0.5 to it. And what that does is if I, let's say, rolled a 5.5, adding 0.5 to that is going to make it a 6. So when I cast it to an int, the decimals are truncated and I get a 6. If I cast 5.5 to an int, it's just going to give me 5 because decimals are cut off. Decimals aren't rounded. Okay, if I want 5.5 to get rounded to 6, first I need to add 0.5 to it, and only then does it become a 6 after I cast the int. And you'll see here that when I do the integer casting, and now when I compile and run, I'm going to get a random number between 1 and 6. This time it was 6, now this time it's going to be 4, now this time it's going to be 2, and the number is random, so on and so forth. Okay? So again, guys, I want to remind us all that I have a Discord server linked in the description. Come ask me questions, come so I can lecture you if you need extra help, whatever the case may be. I'm here to help you guys. We've also got the Princeton Review APCSA books, which are very, very helpful. I recommend you go buy those. And enjoy life.